Um, so, but this portion has a blend of both, except that continuous means calculus part is not there in this syllabus. But this is also a good thing. So, can you little bit start from base theorem and a little bit? Can you little bit show how that link between marginal and when we condition, how we have to approach when something is given, then how to approach?
Okay. Yeah, we can do that. Okay. I think I remember. I think 2 terms back you were in stats or something, right?
Yeah. After that, I was I found maths is pretty much easy, but when it comes to stats, because I took a break and then again I joined.
Yeah, because I remember, I think maybe in Jan term or late term,
Jan term. That was during lockdown period. It was all comfortable. Once the office started, then I was too hectic, so I couldn't focus much. And so only this stats 2 is little bit bothering me because this stats 2 will come everywhere in other higher subjects also. So I don't want to again pass for the sake of passing. I don't want to. So that's why I'm little bit putting some more effort.
Okay. Yeah. We'll do that. Okay.
And okay, before starting, one more thing where I'm facing problem is this bounds, this Markov and Chebyshev. When we have to use up to and when we have to use what you call you got no when to take maximum and minimum.
When to take, it depends mostly on the question sheet, right?
Yeah. How to identify that? That's the thing.
Okay. We will do that too. Okay. So I will start with some basic condition and basic. Okay. So consider you, like I asked you to predict or guess the chances of raining in a country A, let's say. Okay. We have a country A, and I asked you, like, what are the chances of raining there in the month of May, right? So, like, you can make any guess, right? Okay, you can say it is maybe 20% or 30%, like any number you can say, right? But if I provide you with some extra information, like in this country or in that specific state, let's say, this country, we are talking about some specific state, right? So in that state, there is a monsoon season in the month of May. Right. So then if I asked you what are the chances of raining, so you would say then the chances of raining could be 60 or 70%, right? So given this information, right? Given this information, your answer varies.
Correct.
So that is something if I go statistically, conditional probability tells us. Like initially, we know that probability of raining was 20%, right? 20%. And when I get the extra information that it is a monsoon season, then the chances of raining, it becomes 70 by 100. So that's something we call conditional probability, that given some extra information, how is your probability is getting affected. Right? So these are like, we know about something, right? And we are predicting about the future. We are trying to figure out what are the chances of something happening in the future, right? But Bayes' theorem it's like more or less the similar, like broadly, I would say similar to conditional probability. Even the formulation would be same if you see. But the only difference is, okay, let's say I told you that it rained in the month of May, right?
Yes.
There is some event which has already occurred, right?
Yeah.
Just use some fruit color. Yeah. I'm telling you some already occurred event, right? Event that it rained in month of May, right?
Yeah.
And then like it could rain even if it's monsoon season or not a monsoon season, right?
Yeah.
So now I wanted to find out the chances of happening something in past. Like it's same thing, but we know that this thing has occurred, but there's a chance that that uh in past this would have happened. Like what are the chances that it was a monsoon season given that it rained in the month of May? Right? So it's again similar formulation as conditional probability, but it's kind of in base we kind of predict the chances of things that has already happened in past. So you getting the basic difference between the two, right?
Yeah. Here we are assuming that this has happened in the conditional.
Yeah.
Means it's given. It's given that it is. So we have to find what is the intersection within that region. Correct, right? So
yeah,
in
it's
condition.
yeah. Formulation here also it's same, right? It's again the conditional probability, but the sense that we are predicting some past event, that's why we call it Bayesian. Here, the sense that we are predicting about future, we call it just the conditional probability. But the formulation is more or less the same. It's again probability of monsoon intersection rain divided by probability of rain.
Divided by probability of rain. Okay.
Yeah.
See, when I start doing the problem, no. Can you write the conditional one, the marginal one? Can you in parallelly can you write marginal? How to find marginal?
How to find marginal?
Marginal, yeah. No, joint is nothing but marginal into what is that?
Okay, I will go through some tabular format, right? So let's say this is x, this is y over here. It can take value 0 and 1, and x can take value 1 and 2, right? Such type of question you are referring.
Yeah.
Right. So let's say the probability being, let's say, 1 by 8, 2 by 8, 3 by 8, 6, and again 2 by 8.
Okay, 1 minute. Now, for example, we will think that this is independent. Okay, so
Independent.
marginal.
Okay.
Okay. Is it independent? 2, 3.
We need to check for that.
Check for this. Yes. 2 plus 1, 3. 3 by 8 and 5 by 8. 3 by 8 into 4 by 8. No, it won't be.
It won't be. For independence, we need to assign the probabilities based on that formulation.
The thing is that now you told about the base one. Now, if it is independent, we multiply the marginal and we check for the joint, right? So joint, there is a relation, right? Joint equals, what do you call?
Okay. If these two are independent, you can just multiply the marginals to get the joint.
Joint.
Yeah.
Okay. If it is independent, or no, we have one more thing, right? To get the joint. Joint is nothing but marginal by conditional. What is that?
Oh, joint is marginal into conditional.
Joint is marginal into conditional. This and can you write this and base theorem, how it is related? It is something related? No.
Okay. You want to know about that relation? Okay.
Yeah. so that I can get a link, because this forum, this concept, everywhere it is coming.
Okay.
Marginal into conditional is joint, right?
Yeah. Okay. Yeah. So I will just formulate one. Okay. So recall that monsoon season and rain example, right? So given monsoon season, okay. So initially you said the chances of raining was 20%, right? Then given monsoon, the chances of raining, you said it's increased to 0.70, right?
Yes,
So
it has increased. Okay.
Yeah. So somewhat rain and monsoon are kind of linked to each other, right? Depending on if it's monsoon season, your chances of rain increases, right? Okay. And if suppose we say that chances of rain given, let's think of some event, given that it's let's say there is a what can be said about anything you can think of, given that a shop did a sale of 5 lakh. Will your answer for the probability of rain change depending on this event?
No, because there is no
sense
link.
or no link. Yeah. It will remain the same, right? So a shop doing some specific amount of sale and chances of raining, like these two are independent events, right?
Yes, these two are independent. There is no relation.
No relation, right? Okay. And
here in statistical term, no relation means the intersection is 0, correct? Means disjoint, something like that?
No, disjoint is different and independence is different. Okay, let me tell you. So disjoint is there is no intersection, right?
No intersection.
Okay, let's take two event A and B, right? So if I say disjoint, it means their intersection is nothing.
Fine. Nothing. No.
Or you can say empty set.
Empty set.
Okay. And if I say independence, it means that given some extra information, right? Like here, let's discover event A and B.
This is independent.
Yeah, I still get the same stuff. Like my probability of happening of A did not change or is not affected by this event B. Right? So that's when we say, and if you open this up, like if you open the formula and do some manipulation, we get this relation.
This is where I am struck. 1 minute. See, A intersection B equals probability of A into probability of B.
Yeah.
Now joint is nothing but marginal divided by conditional, right? Sorry, joint is marginal into conditional.
Yeah.
So marginal, if we write the marginal, can we write the marginal? Something divided by marginal is P of A divided by B. That is conditional. Into marginal. Marginal is summation.
Okay. Let's suppose my events are dependent, right? What would happen in that case? My probability of A given B, right?
Will change.
It won't be probability of A, it would be something else, right? So to find that, I will apply the formula, right? Probability of B, right? If I do take the probability of B on the left hand side, right? Then I will get
1 minute, Ishan. 1 minute. See, now if we little bit expand this, P of A intersection B is nothing but P of A into P of B, right?
No, that is in case of independence, right? Here I'm saying if they are dependent.
Okay, here this we cannot expand.
Yeah, we cannot
expand, and then P of B and P of B we cannot cancel.
Yeah, we cannot cancel. Yeah, you can only do that in case of independence. But here it's independent.
Okay, here I was doing a mistake because generally I used to expand it and okay. So first we have to identify whether it is independent or dependent. Based on that, we have to work it out. Huh?
Yeah. So if you see here, this is your generally called the joint distribution, right? This is your marginal.
This is my marginal, correct.
And this is your conditional.
Is my conditional.
Right. Now, if your two events are independent, right? If independent, then probability of A given B would be probability of A1, right?
Yes, if it is independent. Yes.
Yeah. Then in that case, I could, instead of A given B, I can write just A, right?
Oh, this is what you are doing. So these both are the same.
Yeah. So in that case, my joint becomes product of marginals, right? This is marginal of A, this is marginal of B. So in case of independence, you can write the joint distribution as product of their marginals. But in case they are not independent, you have to write it as the product of marginal and conditional.
Oh.
So that's the basic difference.
If it is dependent means first we have to calculate the conditional. So conditional will be either more or less than probability of the this one, probability of A. If generally it will be more.
Generally, we can't say it depends on what your information is given.
So it will change basically. It will change.
Yeah, it will change. Because if I give you it's not a monsoon season, then your probability would be less than even.
Less than. Okay. Yeah, makes sense.
It depends on the information given.
Okay, so there is a difference between independent. Okay, this one I got a better idea. Okay.
Yeah. Okay. Any question or something you want to discuss over that? Any question you're struggling with?
No. This is more or less I got an idea. Okay.
Okay. So you will be able to do.
Yeah. One example can we take? I will try to use all you. Okay. So first step is we have to check for dependency or independency, right?
Yeah. Independence is covered in week 3. So in week 3, you will get to know how to check that. Yeah. So in week 7, you are struggling with joint and marginal.
No, week 7, I'm pretty much clear because in that program also it is there. So I got in week 7 where I'm struggling is. Can you go down?
Yeah.
Here, this is fine.
This one?
No, this is also okay. This is also I could manage. Now in week 8, can you take week 8?
Week 8.
You don't have to solve. We can take some similar example. Okay, this is okay. And negative geometric also you just explain later because this question anyway, this no, another one is there. 7, question number 7. What I have done, I will explain first. Question number 7 and question number 6. First, we will take up question number 6.
Question number 6. Okay.
Here, X is geometric 1/5. So I know the so here for geometric, I know the mean E of x is 1 by P.
1 by P, yeah.
So 1 divided by 1 by P is 5. So I got it as 5. This is clear.
Okay,
so next find the probability within one standard deviation of average. So what he is asking is x minus average is mu, x minus mu. Within means less than or equal to. Average is standard deviation is sigma.
Yeah.
So variance is sigma squared is 1 minus p by p squared.
Yeah.
So I got 1 minus 1 by 5 divided by 1 by 25. 4 by 5 into 25. 20.
Yeah.
So sigma I got root of 20 is nothing but 4 5s are 20. So 2 root 5.
Okay. Yeah.
Okay. So x minus 5 is less than or equal to 2 root 5. This is what I got. Now x is less than or equal to 5 plus 2 root 5. And it should be greater than or equal to. Now this is where the confusion starts for me. Now can you write in your board? Okay. X minus 5 mod.
Yeah.
2 root 5. Okay.
Yeah.
Don't go to the left side. 2 root 5. Oh, we have to do it like this. Okay. So you are putting the 2 root 5 both sides.
Yeah, it will be both sides, right?
It will be both sides. X is less than or equal to 2 root 5. Again, x is greater than or equal to 2 root 5 negative. So you are taking the 5 other side. 5.
Yeah.
5 minus 5, 2 root 5. 5 plus 2 root 5.
Yeah.
Now 5 plus some odd number is coming.
This would be something 4 plus, right?
So less than 9.47 something is coming. Here it is 2.5.
It would be 0 point something, right? It would be
0.5 or something. So 0.527. Yeah. Okay, since x should be greater than 0.527, so x should be at least 1. Is it correct? Okay, 1 to 9. 1 to 9. 1 to 9. Okay, that is correct. Well, up to this, I got it. 1 to 9. Now my problem, where I'm struggling, what I'm doing is it probability 9 minus probability 1? How to do it? How to expand this?
Okay, so in general, it is you need to find the CDF till line, right?
So integrate,
not integrate. This is discrete distribution, right? Okay, let me just
somewhere.
Yeah, some. So okay, what does it mean is you need to take probability x equals 1, right? Plus x equals 2 plus so on plus x equals 9.
It cannot be. It won't be like probability 9 minus probability 1. It won't work like that.
It won't. So the easiest way to do is if you look at the number line, right? This is your 0. This is 1, 2, 3, so on up to 9, right? So what I can do is, you know the CDF, right? CDF is nothing but less than equal to x, right?
Less than equal to x, correct.
So if I compute f of 9 first, right? It will take
up to
all this probability 0 to 9, right?
Yeah, and then subtract 1 minus.
But I don't need this value, right? Yeah, so I only need to subtract, I think, probability x equals 0. Yeah, I only need to subtract this probability, right?
Yeah. So, okay, this is a more intelligent way of doing rather than adding everything. And so CDF of CDF to 9 minus probability of 0.
Yeah.
Why we are not doing CDF up to 0? Because 0 to 1. CDF will be from 0 to 1. So see, anyway, 0 is 0, like that.
Yeah. CD of 0, like probability of, if you write f of 0, right? It's same as probability x less than equal to 0, which is same as probability x equals 0, right?
Yeah.
Yeah.
So you are mixing up both.
Yeah.
Okay. So CDF of 9 means if in discrete case, how we are doing for geometric, it is 1 minus 1 minus p whole raised to k. Huh?
Yeah. So 1 minus p raised to the power 9.
Raised to the power 9. 1 minus p is 1 by 5 whole raised to 9. And when it comes to probability of 0 means how?
Okay. So here your geometric distribution takes value from 1, right? 1 to
1. Correct.
So
That is
it
the
would
range.
It is the 0,
0.
right? It cannot take value 0.
It cannot take, correct, because geometric starts minimum is 1.
Yeah.
So 1 minus 1. Okay. So this is the general approach, or this is some unique case what we got?
No, this is general approach. So till this step, right? Till this step, it is general approach.
This is general approach.
Yeah, this is general. After that, depending on distribution, you plug in your probabilities. That's all.
Okay. So the takeaway is you are swapping the sigma, plus sigma and minus sigma, and then you are moving out the mod.
Yeah.
Okay. So, and the trick is probability. Okay, you are making CDF because it is up to 9 1 and then minus probable. If it, for example, if it was 2 means how? P is 2.
If it's 2 over here.
Just a second. 2. What? How we have to do? Since it is 1.
Okay. Yeah. 2 less than x less than equals 9, right? So in that case, you need to add all the probability starting from x equals 2 up to x equals 9, right? So again,
9 we have to add.
Again, I will take the CDF up to 9, right? Which will cover 0 is not there. So it will cover all the probabilities from 1 to 9, right?
Yes, correct.
And then, but I don't need the probability of 1, right? So I can subtract this portion.
Okay.
And suppose if it's from 4, right? If it's 4 to 9, then I don't need 1, 2, and 3, right? So what I can do is I can subtract the region of this region. This region is nothing but f of 3.
Oh, again, you are taking CDF up to 3.
Yeah. I need to subtract the
So
here
also, f of 9 minus f of 0 in the bottom one, what you have done. So f of 0 is nothing but 0.
Yeah.
That is also correct. So we will get, okay. So CDF of 9 minus CDF of 0. Since CDF of 0 is 0, so probability of x is also 0. That is in this geometric, it has become 0. But if it was some other distribution, still
it could have taken some probability. Like in case of binomial, we do have some probability at 0.
Okay. So the best approach is CDF till the last point minus probability till which you don't want.
Yeah.
So this expansion is nothing but Markov and Chebyshev, is it not? Something similar, correct, right?
No. Markov and Chebyshev give you bounds. Like they don't tell you the exact value. Right? Here we are saying that this value is equal to, right? It means I am telling you the exact value. But Markov and Chebyshev tells you bounds, that this value would be less than or greater than. They don't tell you the exact values.
But it
the
is in the similar
approach
way.
is same. Approach is same.
Means
Approach
up
is
to
same.
this step is same, correct? No? X minus something is greater than or less than constant to standard deviation. Okay. Okay, I got a fair idea now. Okay, I got. Okay.
Okay. Anything else? Any other?
And this one, what is that? The negative geometry means what? Because we don't have that one. See, in this question number 4, right? You go to week 8, question number 3 and 4. This is negative geometric, right?
Question number
3.
3. Okay, suppose we toss a fair coin till we obtain 10 heads. It's negative binomial.
Negative binomial. Sorry, negative binomial.
Negative binomial.
So can you little bit explain on this?
Okay. I can do that. Okay, so you know about the geometric distribution, right?
Yeah.
Like what it
to
tells
some
us.
extent, yes.
Okay, let's start with that.
First success.
Yeah, first success, right? So suppose I have a coin, right? And I wanted to know in how many tosses will I get my first heads. So getting the heads is the success for me, and getting a tails is a failure for me, right?
This is how we are defining.
Yeah. So like how many, like my random variable x, it follows geometric, right? With p, right? And if I compute probability x equals 3, so it tells you that you will get your, like, first time you will get your head in the third toss, right? Right? That you get your first success in this many number of trials. You compute the chances of that thing happening, right? But suppose I wanted to know in how many trials will I get 10 heads? Hello?
Yes, I can hear you. Yes.
Yeah. Suppose now I wanted to know in how many trials will I get 10 successes, right?
So which is stopping the experiment when we hit the 10th success.
10th success, yeah. So it's just an expansion of geometric distribution. We call it negative binomial. In geometric, we stop at first success, right? But here we define how many success we need. We need 9 success, 10 success, 12 success. How many success we need, right? So the PMF or the formulation for it is same as that, right? So suppose you are doing n trials, right?
Yeah.
It took you n trials to get R success, right? Okay,
R success.
Let's take X success. X success, right? So what is happening is you are getting your X success in the nth trial, right? Because as soon as you get your X success, you will stop the experiment, right? So X success is we got in the nth trial, right?
Yeah.
Right. So it means in the starting n-1 trials, I got x-1 successes, right?
Yeah.
And
this
then
information is also there.
Yeah. And then in the nth trial, I got my x success, right?
Yes.
Right. So if you closely look at this left portion of this line, it is nothing but binomial distribution, right? In n-1 trials, I need to get x-1 successes.
Okay. Yeah. Yeah.
Right? It would be n-1 minus x-1.
Okay. Okay. Yeah.
Okay. And then in nth trial, you need to get a success. It means what are the chances of getting a success in one trial? That is simply p.
Yeah. 100%.
So if you simplify it, you get this as your PMF for negative binomial.
Oh, yeah. Okay.
This one gets cancelled out, and this one gets cancelled out by this p.
Okay.
So that's what negative binomial is. How many trials will you take to get x successes? While geometric limits to only one success. So expansion of geometric is what you can say is negative binomial.
Okay. Okay. And can you little bit talk on the inequalities, Chebyshev and Markov's?
Okay. In which week it is?
I think it's in 9th week. It is 9th week.
Oh, okay. This Markov and Chebyshev inequalities, right?
And this one, 8th week, what is that? Question number 7, I couldn't understand what it is.
Question number 7. Equal attainment are the positive integers. Oh, it's a hypergeometric distribution.
No, in this program, how many distributions you will be? Any formula they will give?
Okay. Formula sheet you want?
No, in the exam also, will it be provided? Because if it is not provided in previous term, at least in this term, can you implement? Because we have time, right? You still have time.
Okay. I will confirm with the prof and.
No, that's fine. Yeah. It is just a suggestion. You can discuss. Means.
Yeah. Okay. We will do that. Yeah. Okay. Yeah. So week 9, Markov and Chebyshev, right? Yeah. So have you gone through the videos? Yeah.
No, because in that program I have some idea. But when it comes to at most and at least, how to differentiate?
At most and at least. Okay.
Yeah. That is where I'm struggling, because the answers will be same, but when to make it at most and when it will be at least.
Okay, so what is your understanding of at most and at least?
Most means maximum. At least means minimum.
Least means minimum, right? So
correct, right? That is correct, right?
Okay, if I tell you that, okay, so at least and at most you are saying in terms of this or this inequality part?
Sorry. Can you write again? Because
okay, I will just write. This is Markov's inequality, right?
Yeah, this is Markov. So less than or equal to.
So you are struggling with this symbol, right?
Yes, and how to convert from this symbol to greater than or equal to. Sometimes greater than 1 minus some we do, no?
Okay, that part.
Yeah, means we have two types of representation. One is this, and one, if we switch the symbol, then we make it 1 minus.
Okay. That we can do. Okay, so this symbol you understand, right? The probability that your x takes the value greater than or equal to a is at most this, right? Because the probability would be less than this term, right?
This is at most.
This is at most, right? And if I say that this term, then it would be mean that it would be at least this much, right?
It will be, yeah, at least it will be either this or more.
Okay. Okay. Through this form. Okay, now you want to know the conversion of this symbol to this symbol, right? How are we doing the conversion part?
Yeah.
Okay. Okay. So like, okay, that's less than equal to where? Oh, okay. So you haven't seen the lecture here, right? You're still
No, to lecture 9th week I have not started. 9th week I have not started. If it is there in the lecture, then fine. But yeah, up to 8th week I have watched.
8th week. Okay. I can go through it. Shoot.
Okay, in case if you need some time, that's fine, but you can send it the email also, that is okay.
Yeah, I will do that because that's a proof, right? I will send it because it's better if you
go
through video first, right?
No, I will also go through. Yes, I will. So if it is there, then it will be easy. Yeah. That's fine. That is fine.
Yeah.
This is and
okay. Anything else?
One last thing, little bit. One that can you go to that your notes?
In the
go to your note.
whiteboard.
Your notes. Yeah, whiteboard. Your notes.
Okay. Yeah.
Go to that conditional and marginal part and explain once just a summary.
Okay. I have erased it, so I have to write it again.
Oh, you erased it. Oh, I see. Just
okay. So I will write it. A given B, the formulation was A intersection B divided by this, right? If I multiply both sides by probability of B, I got this. Yeah.
Yes.
Why?
No, you don't. This is marginal.
And this is
conditional.
Conditional. Yeah.
So A given B is nothing but A into B if it is.
No, A given B is equal to probability of A only if independent.
If independent.
Yeah.
If it is dependent.
Yeah, reason behind is happening like given this some information, right? It is not affecting your probability. Like if I gave you that information, right? A shop did a sale of 5 lakh. It didn't change the probability of raining for you, right? Those two are independent. But if I gave you the monsoon season, it affected the probability.
So in that case, it will be A into B, is it? Probability of A into probability of B.
Yeah, in case of dependent. Yeah.
In case of dependent.
Yeah, in case of dependent, it would be marginal times conditional. A given B. It will remain the same. We need to compute this probability. But if it's independent, it's not required to compute A given B. Anyway, we will get probability of A only.
Okay, in the reverse way, if you think, if it is independent, if probability of A intersection B equals probability of A into probability of B. So to check for the independency, if we multiply these two and if the intersection is same, then we can claim that it is independent.
Yeah. For independence, we do check only this.
Okay. Can you go to the
which one?
That is why joint. Oh, that is the meaning of joint.
Yeah, intersection is.
Go to that week 8, some tables are there. No? Yeah. This is what week 9.
Yeah, there also we have some independence. Yeah.
So here if you see minus 3, 0.3, 0.2, 0.5, 0.6. So 0.6 into. Okay. So here also we can use the same method. Probability of A into probability of B equals probability of A intersection B. A intersection B is nothing but intersection of X equals -2 and Y equals -2 is 0.3. So if we get the same answer, it is same. Then it is independent.
Yeah. So if you find probability of X equals -2, right? It would be 0.5.
0.5. Yes.
And Y equals to -2
is 0.6.
Yeah.
6 5 are 30. So it is 0.3.
Yeah. But you cannot say independent now. You need to check for all the 4. Only then we can say independent, right?
Okay.
And okay. So I will suggest you do the check for this independence by this intersection formula, right? And find the covariance. If covariance comes out to be 0, then also we say it's independent.
Yes, that is also
yeah.
So and in that program, in that program we have something called if covariance. No, it need not be independent. Also, that case also is there, na? If covariance is 0.
Yeah, because covariance equal to 0 implies linearly independent only.
Linearly independent.
Yeah, but there could be some other quadratic or polynomial relation possible. So we can say only linearly independent.
Linearly independent. So it doesn't mean that. But in some cases, if it is covariance may be.
But if it is given to you that these are independent, then definitely covariance would be 0.
Okay. Covariance
but if covariance is 0, you can only say they are linearly independent. You cannot say that they are independent for sure. Only linearly independent, you can say.
There should not be any X squared or something like that.
Yeah. So for independence, try with that approach, I would say, in the given question. That would be better. Because based on covariance, you can only tell about linear independence, not overall independence.
For overall independence, this is the master. This is the master, is it?
Yeah.
Means this is like a base rule. With that only many things are developed.
Yeah. Base rule is definitely a base to many concepts.
Developed with that approach.
Yeah.
It's a little bit tweaking here and there. We get many ideas. Okay.
Yeah.
Okay. Some idea. Okay.
Anything else?
No issue.
Okay. We will have one more session for your internal exam. We can discuss other stuff there.
And this formula sheet also you propose. We will see.
Yeah. I will do that for sure. Yeah.
Okay. And one more thing. Okay. Before the exam, anyway, we have one more session. It is too early to ask. Anyway, I am more focused on the PSC program, but this is giving me a good idea because it is more or less similar. This is similar.
So, next time probability 2 would also be there if you want to study it more.
No, I will take that. I am very much interested, but without online support, impossible. Yeah, definitely.
Yeah.
it should be like every week. It should not be like this, because this is more or less we can study and get the idea. But that one, when it comes to calculus part and all, we need support.
Yeah, we will try to keep it bi-weekly over there.
Bi-week, yeah.
Every 2 weeks.
Bi-weekly also it will be weekly work. See, I know that many response will be low, but that should not be the reason.
Yeah. We will look into it. Yeah.
Okay, anyway, that's just too early to talk. But anyway, you can just put forth the views, because this is serious subject. This is not something like we need some support.
Yeah, here also, if more sessions are required, we can also keep it more, like till end time we have time, right? So we can also keep.
Yeah, we have some time. A lot of time is there.
Yeah. So
but only thing I'll consolidate my doubts, everything, because I am now focusing on quiz 2. So, but this also is giving a lot of boost to me, because without knowing the basics, we cannot get into details.
Yeah. Okay. So whenever you need the next session, just post it over discussion forum, right? We will schedule one that we can go that way.
Okay. And this R part, how much we have to concentrate? Whatever is there in the assignment, that much is concentration is enough, right?
Yeah. That much is enough.
Yeah, only that commands, if we know it, should be enough. Because I'm not focusing on that, because I'm focusing only on the concept part, because that is what will. Okay. Thanks, Ishan. Thanks.
Yeah. Okay. Thanks, Vishnu. Yeah. Thank you.
Yeah. Thank you.
Bye-bye.